Hello, everyone. Well, this video is to introduce the assignment that we're going to be working with. We're working with this building. So remember that first you have to type your ID here, and then X is the last number. In this case, it's 4. Y is the second last number. In this case, it's 3. So if you're working with this building, this number would be 24 feet. And that number would be 23, and this will be 34 because it's 30 plus x, and x is 4. And this is just to show you how to work with the roofs. We have already worked with walls, and now I'm going to show you how to work with this roof. You have to work with this Excel file. At this point, we have already created the drop-down list. So when we change this material, the conductivity changes, and we have the thermal resistance, thermal transmittance. We have to type the area. This is the UA, and then the thermal load. So if we go back to the brick, remember that on this column, we have the thermal conductivity. Everything comes from this table that we created with the material and thermal conductivity here. If we go to the walls tab, we have this column with the thermal conductivity. We have this column with the thickness. This is something that we have to change. That value changes as we change the material on the list. This value, it's something that you can change. Then that's the thermal resistance. The formula is the thickness, this column D divided by this column C. And the thermal transmittance, all these values should be empty because we calculate the total thermal transmittance, which is 1 divided the total thermal resistance. The total thermal resistance is the sum of this. By the way, this is not included. Okay, so we have to, what about this one? Yep, we have to include the last. Now this last thermal resistance due to the interior air is included. And finally, that's the U value. It's 1 divided by the thermal resistance. That's the wall area. If we have 4 different orientations, you have to measure the wall area of the south, west, east, and north elevations. And then we have to type here the wall area for this is the south, east, north, and west. The areas are different. And this is the UA. UA, it's always the U value times the area. This is something that we can be, yes, in some codes and regulations, we have to provide them with this UA value. And the thermal load is the UA value, this column, times the indoor minus outdoor temperature. So the first values we have here is the indoor and outdoor temperature. And remember that we have this dollar. Okay, so this is the formula. H13 is where the UA value is. And then this is C3, this column, or this cell, C and 3, and D and 3. If we have $Z, $3, and $D, $3, then if we copy this value here, these two cells are the same, but this one without the dollar, this cell changes. Okay, so that's why we used this dollar sign to make sure that these two columns that are fixed, they don't change. We can change this value, and then all the thermal loads will change accordingly. So that's the wall. Then we go back to the roof, and on the roof, for each roof, we have to create 2 different tables. One of the table is for the part of the roof that has to do with the rafter, and the other table is the part of the roof that has thermal insulation. It is important to understand what a roof is. Okay, it can be flat or it can be tilted roof, but in most residential buildings, this is the kind of structure that we have. We have those rafters or joists. Usually a rafter is something that it's tilted. A joist, it's more for a flat roof. But anyway, there is a wooden structural element. We have thermal insulation filling this gap between the rafter, between two rafters. And then we can have different layers. They are at least the indoor finish and the outdoor finish. And well, you can see here different parts. We can fill this with thermal insulation, or we can have part with thermal insulation, and then we can have a gap, an air gap here. It depends. But what we have to understand is that in this detail, we have two different sections. We have this section through the thermal insulation. We have this section through the rafter. The size of the rafters, usually it's 2 inches. The width is 2 inches and the height is 6. It can be different, of course, but those are standard elements. So those are standard dimensions. So keeping that in mind, you see that here we have a lot of details, but it's always the same. We always have joists or rafters. We have a space between rafters. We can fill that space with thermal insulation. If we don't have any insulation, it's even worse, but usually we have thermal insulation here. And then we have different layers. What are the layers that we are working with in this assignment? We are working with first asphalt shingles, then a ventilated air cavity, then we have the fiberglass and the rafters, then we have another air cavity, and we have gypsum board indoors. If we go to the Excel file, we have two sections. We have the section through the rafter, the section through the thermal insulation. This is the size of the rafter, the width of the rafter. It's 2, and the space between rafters is 14. So that's the space that we fill with thermal insulation. And here we have all the materials. We have asphalt, we have the air ventilated cavity. This is the timber, pine, and this is the fiberglass. To make sure that we understand this, we can have like another color here. And the same layer, it's the timber and the fiberglass. The rest of the materials are the same: asphalt, air cavity, gypsum. We have asphalt, air cavity, and gypsum. But this is different. In this case, we have the width is the same, it's 6 inches, but the thermal conductivity is different because here we have a timber, that's the rafter or the joist, and here we have the fiberglass, which is the thermal insulation. So we have to create 2 tables, and here we can change the size of a rafter. If instead of 2 inches, it's 4, we can change it. If the space between rafters, instead of 14, it's 20, we can change it, okay? But let's abide by these, 2 and 14. And we have this concept. We can calculate the thermal resistance, the same thing. Again, drag this down and drag this down. The thermal transmittance is 1 divided by this. We have a thermal transmittance through the rafter as different thermal transmittance through the thermal insulation. This is 0.08, this is 0.03. And we have this concept of U average. Okay, so what's the U average? That's the formula. So I'm going to type the formula. The formula, as we have to write in Revit, is always like this: equals, then the first parenthesis, the second. So we have the U value of the rafter, make this font smaller. So that's the U value of the rafter times the thickness of the rafter. In this case, it's 2. It's bigger, 2 inches. And I close this parenthesis. Then this is plus. I'm copying this. That's not the U value of the rafter. This is the U value of the thermal insulation times, and this is not 2 inches, this is 14, because that's the space between rafters. Okay, so I have this product. This is times. And then I have to close this parenthesis. Now I have to divide by 2 inches plus 14 inches. 2. So this is the formula that I have to write in this in the Excel file. So first parenthesis, second one, F14. It's the U value F14 of the part of the roof that we have, the rafter, plus A5. A5, it's 2. It's the width of the rafter. F26 is the U value of the part of the roof through the thermal insulation. A17 is 14, and then divided by A5 plus A17. It's 2 plus 14. Okay, so we can type here 2, 14, but if we change the size of the roof, or we change the size of the rafters, or the distance between rafters, we have to do this again. If we type here these two, or if we refer to these two cells, if we change the values on these two cells, this value will change accordingly. I'm going to make these 3 decimal places. And the UA, I'm going to format this to number 2 decimal places. The same thing here, 2 decimal places, format cell, number, 2 decimal places, and then I can copy the format and click here. Yeah, 2 decimal places, it's enough. Units, BTU hours of the thermal load. Okay, this is the total. So far, we only have one roof. If we had another roof, we can copy all these. We can insert copied cells. And here there will be a roof 2, again through the rafter, and a roof 2 through the thermal insulation. Remove, if we have the same roof, we don't need this text, because this column, it's just for the heating load. And imagine that we change this roof because it's different. We don't have, imagine that we have 4 inches for this value will be different. And if we have 2 different roofs, what do I have to add? I have to add up. I have to change this to a function. The sum of, and I have to select all the values on this column. Okay, so that will be the total thermal load through roof 1 and roof 2. The same thing we have done with the walls. So, okay, so for the walls, we have copied this table, and then we have the total thermal load, which is the sum of all these cells. Okay, Revit is good enough, and even if it finds text, it only adds up the numbers, okay? But I would delete it to make it easier. We'll keep only the first one. Okay. So the same thing with the roof. We just have to do this. In the event that we have two different roofs, in the assignment, we only have one roof, okay? So if there is only one roof, we don't need all these. And we can delete all these cells. And we only have one kind of roof. Finally, we have to do the same with windows. For the window, we just have, we don't have all this stuff. We will look at this next week because we will need to add different parameters. But so far, the only information we have from the window is the thermal transmittance. We have the thermal transmittance, we have the area of the window, and then we have the UA, and then the thermal load, which is, again, the UA times indoor minus outdoor temperature. And where can we find this thermal transmittance? On Canvas, this module, I uploaded a catalog, the U factor for Windows, so we can look at this. And when it comes to Windows, the manufacturer or the company provides us with this value. Okay, so that's the U factor. In this case here, we have the specifications. It's triple insulating glass, argon fill, low emissivity, warm edge spacer. So this is probably the best, or one of the best triple glazing we have available in the market. I have already explained in lesson what all these things mean. But if we select this value, this U factor, with these units, BTU feet square, hour, Fahrenheit, then here in Windows, this is BTU feet square Fahrenheit hour. On this value, I have to type 0.18. Okay, and then if all the windows are the same in all the orientations, we can change this. And then for the door, we just need a door. It's a wooden door. And well, that's correct. If you type here, if you know the thermal conductivity of that wood and you know the thickness, we know this and we know the thermal transmittance. Or we can go to a catalog, okay, but that's fine. And then we need the area of the door as well. So for windows and doors, it's easier, especially for windows. We only need to type the U value, and then with this structure, with the U value in the area, we have the thermal loads, and again, the total thermal loads of the window. We have to add all this up. Clicking this. So we are on our way to create like a meaningful Excel file with all the thermal loads. At the end, there will be another tab and we will have like a summary and we will have thermal loads through the windows. We will write this number, thermal loads through the floors. I will explain the floors later, through the roofs, through the walls. And at the end, we will have like a summary of the building. But today we were focusing on the roof, and this is the right structure for the roof.